the University of Arizona, researchers and scientists are one step closer towards the launch of Pandora.
It is a satellite tool that will help discover planets with potential livable conditions like Earth's.
Our very own 13 News reporter Andres Rendon joining us live this morning from the U of A. Andres, how exactly did this all start?
All right, guys, so this really kind of started around 7, maybe 8 years ago when a graduate student here at the University of Arizona was kind of noticing an inconsistency using the James Webb Telescope. And when he was trying to look at these exoplanets, those are the ones that potentially may have life or we might be able to live on, well, that seemed to be a challenge. So out of those 7 years ago, this kind of prompted the need to create a better tool for the future. Take a listen.
We realized that disentangling what comes from a planet and what comes from the star is going to be more challenging than we anticipated. So we described a need to complement James Webb observations with additional sources, better understand the stars, so we can subtract better the signal of the stars, and it pushes us closer to understanding what the atmospheres of these potentially Earth-like planets may be made of.
So starting off, we're going to look at the larger picture of the mission, and that's to discover planets that we may be potentially able to live on, but of course that's years and years and years in the future. But in order to do so, we need to better analyze the elements in the atmosphere of exoplanets that orbits the stars in the galaxy. So the creation of the James Webb Telescope has already added great knowledge and observations, but when it comes to looking at those atmospheres of these exoplanets, what's happening is that the telescope is kind of mixing up the light from the stars it orbits instead of the exoplanet alone. So Pandora comes in. It's a small satellite, and it was created to avoid this issue, better differentiating the signals coming from the stars and the exoplanets orbiting them. Scientists then use the light wavelengths to determine what elements are present and their quantities. But another thing, though, the satellite also dedicates its time and use to analyzing the lights and elements from the exoplanet's exclusivity, since James Webb isn't able to do so with its high demand.
We will have up to 5 downlink passes per 24 hours. And at that point, we have to look at an antenna here on Earth because we will be transmitting an X-band. But otherwise, we will be observing primary targets and secondary targets throughout the entire day, every day.
So most recently, the mission had already completed its bus, that's also kind of known as the main computer system, and they're going to be starting their environmental testing of the launch this month. And this is all ahead of the main orbit come the fall. Now, a little bit though for the University of Arizona. It's going to have its very first astrophysics mission right here on campus. We're going to tell you a little bit more about that coming up later on 13 News. Reporting live from campus, Andres Rendon, 13 News.